Okay, this is going to be about linear functions. I just am kind of picking and choosing, looking at some of your problems. Like question number 1 says, is this y equals 1/7 x plus 3? Determine whether it is increasing or decreasing. Remember, y equals mx plus b, where that is your slope, the m. If it is positive, it's increasing. If it is negative, it is decreasing. So it looks to me like this function is definitely increasing because that is positive. All right, and then this question asks, match the description of the relationship between inputs are x, outputs are f of x. So you can visualize these that says the output value, so this is my x and this is my f of x. So it says the output values decrease as the input values increase. So that would be something like this, right? That I would see that my output, okay, my output values are decreasing as my input values are increasing. I don't know what I just said. All right, so then the output values increase as the input values increase. So they're both increasing. F of x is going up and so is x is going up. It says the values neither increase nor decrease. That would be a constant function. Notice there's nothing increasing or decreasing. All right. I'm just kind of looking through some of the questions. Question 5, I can grab some of these. So this is question number 5, a word problem. It says a hiking trail, not too thick, a hiking trail down the side of Mount Lloyd drops at a vertical distance of 10 meters. And it drops, that tells me this is going to be a negative number, and over a horizontal distance of 1100 meters. So the slope dropping then would simply be 10 over 1100, or it said to definitely reduce it, which would be negative 1 over 110. If I have an actual graph, and they want me to find the slope. So let's say I have this graph right here, and they say using this graph, find the slope. Remember, to find the slope is y2 minus y1 over x2 minus x1, which means you have 2 points. If I can write y1 and x2, y2. So you want to look on the graph where you can get exactly points. It looks like I can get one right there. If you can get them at intercepts, that's always nice, right? So the y-intercept and the x-intercept. So my first point looks like that would be negative 2, 0. And my second point looks like that would be 0, 8. So the differences in my y's would be 8 minus 0. My differences in my x's would be 0 minus a negative 2. A negative and a negative is a positive, so it looks like that slope would be 4. Looking at something like question 7, it says determine the equation of the line, and I'm given a point and a slope. So why not use the point slope formula, which is y minus y1 equals m times x minus x1. And it says put your answer in slope intercept form, which is y equals mx plus b. So this is my y1 value, this is my x1 value, and that's my slope. So plugging everything in, I get y minus 17 equals 7 times x minus 2. To put it in slope-intercept form basically just means to solve it for y. So 7x minus 14 distributed. And then I'm going to add 17 on both sides, and I get y equals 7x plus 3. Okay, and the last one, question number 8, is a word problem, our favorite, right? But this is why you're here, where you can understand how all these x's and y's and f of x and all this can actually be put into equation. So it says a clothing business finds there is a linear relationship. Does that look familiar? They just changed the variables around between the number of shirts in. So n equals number of shirts. This is kind of how I do word problems, is I make some notes here. It can sell, and the price, P, of course, would be price. It can sell per shirt, price per shirt. In particular, historical data shows that 4,000 shirts can be sold at a price of $95. So 4,000 shirts at a total of $95, while 12,000 shirts at $39. So if you think about this, when you first read it, you're like, I have no idea what they want me to do. I'm going to draw this out and see if this helps a little bit. So these are actually points here. So let's call this the dollars, and let's call this the shirts. And so if I'm at 4,000 shirts, then I'm at $95. That's just a point, 4,095. I can do the same thing here. If I'm 12,000, then I'm at, not drawn to scale, but then I'm at that point. And so this is how now you might be like, oh, I see now you have 2 points. So I can simply find the slope. And looking at this, just, you know, this, I'm trying to find the equation of that ugly crooked line. I know my slope's a negative because it's decreasing, right? So the first thing I want to do is I want to find my slope, which is going to be the differences in my y's over the differences in my x's. What is it, 4,000? And so I take 39 minus 95, and I get negative 56. And I take 12,000 minus 4,000, and I get 8,000. And I'm going to go ahead and put this in as a decimal. So I get negative 0.007. All right, so that's my slope. And now from here, I can pick either point and use the point slope formula. So I can use y minus y1. I'm going to use, I don't think it matters. I'm going to use this point. It doesn't matter, you'll get the same answer. I was just trying to get smaller numbers to deal with. So y1 is 95. We just found our slope. And I believe somewhere they're using n. So that is my slope. Well, I'll just write it this way at first, and then we can put it in the form they want it. And then that was what, 4,000? Right, so I'm picking that point. So I have y minus 95 equals negative 0.007x, a negative, and a negative is going to be a positive. And so then 4,000 times that value gives me 28. And then I'm going to add 95 on both sides. So y equals negative 0.007x plus 123. And then the last thing to do is just put it in the format they wanted it in. So the P equals negative 0.007n plus 123. And there it is. You now have an equation that you could actually use. You could just plug in. Notice here, n's the number of shirts. You could plug in a value for n and you could actually get the price.